Hi guys, my name is Ramprasad. I am saying about the operating system lab experiment number 8, page replacement algorithm. Let's see the aim. Write a C++ program or Python program to simulate page replacement algorithm. FIFO LRUC optional. Description: page replacement is basic to demand paging completes completes the separation between logical memory and physical memory, which is mechanism and enormous virtual memory can be provided for programs on a smaller physical memory. There are many different page replacement algorithms. Every operating system probably has its own replacement scheme. A FIFO replacement algorithm associates with each page the time when that page was brought into memory. When a page must be replaced, the oldest page is chosen. If the if the recent past is used as an approximate of near future, then the page has to be looked for longest period of time can be replaced. This approach is the least recently used LRU algorithm. LRU replacement page last used. When a page must be replaced, LRU chooses the page that has been used for the longest period of time. Least frequently used LFU page replacement algorithm requires that the page with the smallest amount be replaced. The reason for the selection is that an activity used page should have a large reference count. In an operating system that uses page replacement algorithm is needed to decide which page needs to be replaced when new page comes in. Page fault. A page fault happens when an running program accesses a memory page that is mapped into the virtual address space but not loaded in physical memory. Since actual physical memory is much smaller than virtual memory, page faults happen. In a case page fault, operating system might have to replace one of the existing pages with the newly needed page. Different page replacement algorithms suggest different ways to decide which page is to replace. The target for the all algorithms is to reduce the number of page hits. If we if we find the required page in the main memory while CPU wants to access the page when it's a page, they are called as page faults. For page faults, we have to look secondary memory and fit the required page are loaded into the main memory algorithm. Find the location of the disk, desired page on the disk. Find a free frame. If there is a free frame, use it. If there is no free frame, use a page replacement algorithm to select a victim frame. Write the victim frame to the disk, change the page and frame tables accordingly. Read the desired page into the newly freed frame. Change the page and frame tables. Continue the user process from where the page fault occur. First in, first out, FIFO. This is the simplest page replacement algorithm. In this algorithm, the algorithm system keeps track of all pages in the memory queue. The oldest page is the front of the queue. When a page needs to replace a page in the front of the queue is selected from removal. Example: consider reference string 130356 with 3 page frames. Find number of page frames faults page frame, and we can see the examples here. I like that example 2 and example 3. And let's see the sample output. Number of frames is equals to 3. Reference string 701230430212011701. Number of hits 11. Number of misses 9. Number of frames fn is equals to 4. Reference string 701230423032. Number of hits 7. Number of misses is equals to 6. And let's see the program. Hash include bits stdc++.h using namespace std void print q int q while q.empty count q.front q.pop cout less than n1 bool check value q less than int greater than q int temp bool t is equals to 0 while q dot empty. If q dot front is equals to temp, t is equals to 1 break, else q dot pop return t void FIFO into index is equals to -1 into n frame temp page f is equals to 0 hits is equals to 0. See out enter the number of reference of and frame slots. See in greater than n greater than frame q less than int q. See out enter the page reference in sequence. For int I is equals to 0, I less than n, I plus plus. See in the greater than temp. If check value q temp hits a plus plus, continue else page if f plus plus. If index greater than is equals to frame -1, q dot pop q dot push, else q dot push index plus plus. See out less than n page faults page f n hits and bool search int key vector int and fr for int I is equals to 0 I less than fr size I plus plus. If fr I is equals to key return true return false. Int predict int page vector int fr int pn int index int res is equals to -1 for test is equals to index for int I is equals to 0 I less than for size I plus plus int j for j is equals to index j less than pn j plus plus. If for I is equals to pg j, if j greater than for the rest for test is equals to j less I break. If j is equals to pn return I return res is equals to -1 0 res void optimal system clear vector int f int hit is equals to 0 int n frame layout enter the number of reference and frame slots. See in n frame int page see out enter the page reference in sequence. For int I is equals to 0 I less than n I plus plus. See in page for I int I is equals to 0 I less than n I plus plus. If such page comma f hit plus plus continue. If f dot size less than frame f dot push back page, else int j is equals to predict page f comma n comma 1 plus I plus 1. Fj is equals to page I. See out page faults less than n minus hits less than hit void list int n comma frame page is f is equals to 0. See out enter number of reference and frame slots. See in n greater than frame int pages and see out less than enter the page reference and sequence minus n. For int I is equals to 0 I less than n I plus plus. See in pages under unordered set int s unordered map int comma int indexes. For int I is equals to 0 I less than n I plus plus. If s dot size less than frame, if s dot page find pages is equals to s dot n s dot insert pages page f plus plus indexes pages is equals to I, else if s dot find pages is equals to s dot n int lru is equals to int maximum value. For auto it is equals to s dot begin it is equals to s dot end it plus plus. For if indexes it less than lru is equals to indexes height it value star it dash dot arrays value s dot insert pages I page f plus plus indexes pages I is equals to I. See out less than n page faults page f n t hits less than n minus page f n and see out which choose the page replacement algorithm. See out ta fifo tb optimal page replacement tc least recent used least recent and tx exit char choice c in choice switch choice case a fifo breaks case b optimal break case c least break case x break and return 0. And let's run the program. First one, giving optional A. Enter number 13 space 4 and enter the page reference in sequence 7 0 2 3 0 7 0 1 2 0 3 0 3 0 4 2 3 0 3 2 and page for 7 and let's see next one. Optional B 13 space 4 7 0 1 2 0 3 0 4 2 3 0 3 2 and page for 6 hits 7 and let's see the next one. C 13 7 0 1 2 0 3 0 3 C 13 7 0 1 2 0 3 0 4 2 3 0 3 2 and thank you guys by watching my video.